So in this exercise, we have to compute per capita capital production and consumption in the steady state as a function of savings rate S, depreciation rate delta, and the natural rate of unemployment. So this production function here assumes that there is unemployment, and production is still carried out by the use of labor and capital. So writing up the production function, we can rewrite the production function to k to the power of 1/4 times 1 minus the natural employment rate to the power of 3/4 times n to the power of 3/4. So the first thing that we have to do in exercise 4.1 is to state the steady state condition. Why? Well, we have to find the steady state values, so always state the steady state condition, so you always can recall it afterwards. State the steady state condition. And what does the steady state condition say? Well, the steady state condition says that delta times k over n should be equal to the savings rate times y over n. Now, step number 2. What we would like to do now is that we would like to compute the capital stock per worker in steady state, but in order to do this, we have to replace the output per worker in the steady state condition. So in order to replace y over n, we have to find an expression for y over n. So find an expression for y over n. So in order to replace the y over n in the steady state condition, we need to find an expression for the output per worker. And the only way to do that is to compute output per worker. Remember, the production function is this. So we use the production function in order to compute the output per worker. So y over n must be equal to k to the power of 1/4 times 1 minus the natural rate of unemployment to the power of 3/4 times n to the power of 3/4, and this we divide by n, which now is the labor force and not the number of employed workers, since we now assume unemployment in our model. This we can rewrite to k over 1/4 times 1 minus un to the power of 3/4 times n to the power of 3/4 over n. This we can simplify. This is the same as n to the power of 3/4 minus 1, which is the same as n to the power of minus 1/4. So we get that the output per worker function, or the expression for the output per worker, is k to the power of 1/4 times 1 minus the natural employment rate to the power of 3/4 times n to the power of minus 1/4. This we can rewrite a bit. This is the same as 1 minus the natural rate of unemployment to the power of 3/4 times k to the power of 1/4 times n to the power of minus 1/4. And these two we can collect like we have done before in all of our previous exercises. This is the same as k over n to the power of 1/4. So in other words, output per worker What is the output per worker? Output per worker is 1 minus the natural rate of unemployment to the power of 3/4 times K over N to the power of 1/4. So now we have an expression for output per worker. So now when we have an expression for output per worker, we simply plug this expression into our steady state condition in step number 1. Once we plug in the expression for the output per worker in steady state, we have one unknown, and that unknown it will be capital per worker in steady state. And when capital per worker in steady state is the only unknown, we can solve for the capital stock per worker in steady state and compute all the values for both capital per worker in steady state, output per worker in steady state, and also consumption per worker in steady state. So what would we do now? So in step 3, insert output per worker into the steady state condition. What was the steady state condition? That was the delta times K over N. That should be equal to the savings rate times output per worker. Now that we have an expression for the output per worker, we remove this and plug in the exact expression, which is 1 minus the natural rate of unemployment to the power of 3/4 times K over N to the power of 1/4. Now what I do is that I divide both the left and right hand side by delta. So delta cancels out. So we have on the left hand side of the equality sign, we have K over N. That should be equal to the savings rate over the depreciation rate times 1 minus the natural rate of unemployment to the power of 3/4 times K over N to the power of 1/4. So now what we would like to do is that we would like to solve for the capital stock per worker in steady state. How do we do that? Well, we have to solve for K over N. We have to isolate K over N. So I divide both the left and right hand side by K over N to the power of 1/4. So now I have to do the same on both sides. These two cancels out. So on the left hand side, I have K over N over K over N to the power of 1/4. That is the same as K over N to the power of 3/4. Okay, so remember we use this rule here. X to the power of M over X to the power of N is always equal to X to the power of M minus N. And of course this should be equal to the savings rate over delta times 1 minus the natural rate of unemployment to the power of 3/4. How do we solve for the capital stock per worker? So if we just write up the capital stock per worker here below, we have a K over N to the power of 3/4 should be equal to the saving rate over delta times 1 minus the natural rate of unemployment to the power of 3/4. So how to solve for the capital stock per worker in steady state? we take both the left and the right hand side to the power of the inverse of 3/4. What is the inverse? Well, the inverse is 4 over 3. So now I have to do the same on the right hand side of the equality sign. We get 4 over 3. And then I have k. Then I have here k over n to the power of 3/4 to the power of 4 over 3. So 3 over 4 times 4 over 3 is equal to 1. So we end up by having only k over n on the left hand side. So that is just k over n. And here we just simplify this expression. We put this exponent up here, and we multiply this exponent here with this exponent here. Now we just, simplify our expression a little bit. So k over n, the capital stock per worker in steady state, is equal to the savings rate over delta to the power of 4 over 3 times 1 minus the natural rate of unemployment to the power of 3 over 4 times 4 over 3. That is just a 1. So we have the capital stock per worker in steady state is equal to the saving rate over delta to the power of 4 over 3 times 1 minus the natural rate of unemployment. So this here is the capital stock per worker in steady state. So now that we have our capital stock per worker in steady state, we can also compute output per worker in steady state. And what was the output per worker in steady state? So here I write output per worker in steady state. What was that? Well, the output per worker in steady state we found here is this yellow one. So we write up this expression, y over n. What is y over n? That was k over n to the power of a quarter times 1 minus the natural rate of unemployment to the power of 3/4. So in order to get the output per worker in steady state, we plug in the capital stock per worker in steady state inside the output per worker function. So if we do so, we get that y over n is equal to the capital stock per worker, which is saving rate over delta to the power of 4 over 3 times 1 minus the natural rate of unemployment, everything raised to a quarter, times 1 minus the natural rate of unemployment. This we can simplify. This is the same as the saving rate over delta to the power of 4 over 3 times 1/4. That is just 1/3. So remember, I multiplied this exponent with this exponent, and then times 1 minus the natural rate of unemployment to the power of 1/4 times 1 minus the natural rate of unemployment to the power of 3/4. And these two terms here I can collect. Okay? So assume that 1 minus un is equal to x. Then we have x to the power of 1/4 times x to the power of 3/4. And that is just equal to x. Okay? That means that this here must be equal to 1 minus the natural rate of unemployment. So output per worker is equal to the saving rate over delta to the power of 1/3 times 1 minus the natural rate of unemployment. Okay? As the natural rate of unemployment increases, we will have fewer workers and therefore fewer people to generate any production and income. And as a result, output and production per worker will therefore decrease. This is very intuitive. If UN increases, if we have more people unemployed, well then also if the unemployment rate increases, also production will decrease, because production depends positively negatively on the unemployment rate. Okay, so this is very intuitively is if we have a higher unemployment rate, we will have fewer workers in our production and therefore also a lower production. Lastly, we have to compute, and of course this here is in steady state. Lastly, we have to compute consumption per worker in steady state. Consumption per worker in steady state is 1 minus S times output per worker in steady state. So we simply replace the output per worker with the exact expression that we have right here. So we get 1 minus S times S over delta to the power of 1/3 times 1 minus the natural rate of unemployment. This here is the consumption per worker in steady state.